We next have Dr. John Kupfer. He's going to be discussing implications of 21st century climate change for prescribed burning in the Southeast. John's a friend and a professor and past chair at the Department of Geography at the University of South Carolina. His research couples fieldwork with spatial analysis and GIS-based modeling to explore interactive effects of landscape transformations. He is working on projects through the Southeast Climate Adaptation Science Center at USGS, and happens to be an expert in the geography of barbecue sauces, a lesser known fact. John, take it away.
All right, thanks, Kevin. All right, I almost decided to try and log out after Mike's talk and feign technological problems because that's a hard one to follow. But I decided to instead take advantage of it. So Mike, if you see anything in this, let me know at the end of the talk and I'll hold it up for you. So all that said, it really was a great intro for what I want to talk about, which is these issues associated with projecting forward in time rather than looking retrospectively as Mike was doing in his work. Another thing I'll add is that much of what I'll be talking about today is I'm presenting it, but it really is part of this group that Kevin just alluded to a couple of minutes ago. That includes him, Adam Tarando, who's up at NC State and with USGS at the Southeast Climate Adaptation Science Center, and Peng Gao, who is at UNC Wilmington. And then bits and pieces of what I'll be talking about actually also bring in some of our collaborations with other folks, both here and at other places around the region. This all started, by the way, about 6 years ago. And it was through a grant called the Vital Futures Project that was eventually funded by the USGS and by the Regional Climate Adaptation Science Center. And it brought together folks at USC, NC State, and then folks with the National Wildlife Federation. And the goal of this was to look at ways of designing and implementing strategies that are not just sort of backwards facing or not trying to meet certain goals, but to look forward to what some of the near and longer term threats to biodiversity in the Southeast are all about. That's included work that we've done on urbanization and other types of issues as well. But of course, with today, what I want to talk about is anthropogenic climate change, although that in and of itself is going to be interrelated to some degree with patterns of land use change and urbanization as we look forward over the next 70 to 80 years. I'm sure most of you guys have seen graphics that look like this, and I pulled out just a few of them just to highlight the idea that as we look forward over the remainder of the 21st century, models have predicted a range of different changes, which in turn are going to influence fire. Whether that's things like overall trends and mean temperatures, whether that's, as you can see on the right here, things like projected changes in the number of days over 95 degrees Fahrenheit. That's going to be significant because when we look at things like summer burning, those types of changes seasonally can be very important in terms of the types of responses that managers might have. Future predictions of temperature are probably pretty good. Future predictions of precipitation and moisture are a little bit more variable. And that's something that I'll sort of come back to periodically over the course of today's talk. The linkage, of course, to what I want to talk about today and why Kevin asked me to speak is that those projections are for almost all of the Southeast, looking at warmer and drier conditions for the remainder of the century. That's likely to be coupled with more drought, with more sporadic and prolonged dry periods, a longer fire season, and all of that, if you think about the ways in which those climatic changes will influence a range of different ecosystem services, well, fire is one of those, and that's likely to increase wildfire risk. Some previous work has projected for the southeastern US that the result would be something like at least a 30% increase just from 2011 in the area that's burned by lightning ignited wildfire over roughly the 50 years following that. In another recent paper that actually brings together Mike Stambaugh, who you just saw, and Kevin and myself and my colleagues, we just published this recently in Science of the Total Environment. And it was using a model that Mike had a couple of slides up during his talk about called PC2FM. And what the results were, and we did it nationally, but I pulled out just sort of the southeastern areas that would be relevant to us, are significant increases in annual fire probability amounts. And this is even in areas that, as he talked about, are places that have historically had very, very, very high fire frequencies. The results differ a little bit depending on how much the climate actually changes. That's what the top panel versus the top panel is doing. That's something that I'll talk about in just a minute. But the notion is that throughout the region, what we're seeing are changes from sort of a historical baseline of increased fire probabilities ranging from 30 or 40% in the areas that are sort of tannish, up to frequencies that might be about twice as often as they historically were in the areas that are in the darkest red. Okay, so the idea is, and this is not factoring in ignitions, by the way, this model was basically focusing on fuel production, drying of the leaf and duff layer, and other things that if a fire does start, that would be likely responsible for that fire spreading, and then for resulting in changes in what the fire regime in those locations would be like. Now, a couple of folks earlier in the day talked about this, and when I do some of the work in my classes that I teach here at ESC, my students are always most familiar with what you see here because this is what's in the news, right? The things that we see when it comes to climate change and its linkages to fire and its linkages to humans. We see these big things associated with wildfires, oftentimes in California, or if you go back a couple of years, the bushfires that we had in Australia. So the emphasis has oftentimes been really on wildfire and what the implications of that were. And Mike even touched on that just a second ago in response to a question. Even here in the Southeast, I'm sure a lot of you remember just 5 years ago, the wildfire outbreak that we had throughout Georgia and Tennessee, and especially in Western North Carolina, which was tied obviously with some human ignitions, but were occurring in areas that in some places really hadn't had measurable rain, in some cases for more than a month. Now, can you link that directly to climate change? Some people will say no, because it's an individual event and it's not like droughts were just invented within the last few years. But the projections are that droughts in these longer term periods with low rainfall are expected to become more and more common as we go forward in time. So the idea is we start to think about this and we associate climate change and fire so much with wildfire, because these are things that we see in social media and they're things that we see on the nightly news. The reality for us here in the Southeast is that despite all that, the area burned in the US by prescribed fires each year vastly exceeds that burned by wildfires. And as you guys know, managers in the Southeast conduct prescribed burns on 7 to 8 million acres annually. So while the big wildfires might be the ones that get the press and the attention, the implications of climate change for prescribed burning are something that hasn't been looked at as much, and they maybe don't receive as much popular attention, although it's something that's directly relevant to those of you guys who are sitting in on this workshop today. That's important for a range of reasons, which y'all know. People burn for a range of different issues to achieve different ends or means. The graphics here, this is just one example from Eglin and from Fort Benning. And in this case, it is that as you reintroduce more and more prescribed fire into these areas, there's a benefit to reducing the number of wildfires, right? So we might burn for a range of other reasons, and much of what we've been doing recently has been in longleaf stands. But this idea of one of the ways to prevent increasing wildfires in the region is to burn. We all know that. But it's something that we then need to start thinking about, well, how does climate change influence prescribed burning in these areas? All right, so what this led to is a project that was supported by the USGS, and the focus was to project the potential effects of climate change on opportunities for prescribed burning in the region. The way that we did that was by looking at projected future changes in days that meet just some very basic prescription window parameters using recent weather data and then climate change models through the end of the 21st century. Now, the idea of prescribed burn windows is something, again, that you guys all know, but it's the idea that there are a suitable range of conditions within which a prescribed fire can be conducted. Those might be weather-based, they might be related to fuels, they can be related to other things as well. But we'll define them in terms of 3 fairly simple parameters that I'll talk about in the next slide. What we did to get at this was we looked at burn permits. We pulled almost 250,000 broadcast burn permits over an 11-year period from Georgia and from Florida. And then for those days on which the fires were being permitted, we linked those to weather conditions on those days. And those were extracted from weather databases. As we went through this, we actually started with a couple of potential measures of burn windows. We arrived at 3, and we arrived at these and we got to the numbers that we got to in part by talking with practitioners, by looking through GrayLit, by looking at some of the different burn permits that are used in different areas throughout the Southeast. And what we arrived at were 3 things. Okay. These, by the way, are also weather parameters that if you look forward and you look at output from global climate models or general circulation models, these are things that we can have a continuous record of projections running all throughout the next 80 years. And we'll talk about why that's important in just a couple of minutes. So the things we came up with were basically noontime temperature, and we set the window at from 32 degrees Fahrenheit up to 90.5 degrees Fahrenheit. Relative humidity at conditions above 30%. Below that, we get into red flag conditions and some other problems. And then mean daily wind speeds between 5 and 18 miles per hour. Now, what you see on these graphics are the frequency of days that fell within each of those conditions. And the red bars here represent the thresholds. So all of these days are days in which the permitted fires were within that threshold of 0 to 32.5 degrees Celsius, or we're above 30% humidity, or we're between average daily wind speeds of 5 to 18 miles per hour. Now, we know there's some things that fall outside of that, and there's a couple of reasons that I can talk about why that might be. But despite that, if you look at those records, 97% of the days on which permits were requested took place within conditions that fit all 3 of those parameters. So sort of a Goldilocks and the 3 bears kind of thing. So it wasn't too hot, it wasn't too cold, it wasn't not humid enough or too dry, it wasn't too windy, and it wasn't too still. Even better, if you look at different ways of kind of considering this, we have less than 2% of permits were requested under conditions warmer than the temperature. And you can see there's a really distinct drop-off once you get to warmer and warmer conditions. And those fires that were outside of that threshold accounted for less than 1/2 of, excuse me, less than 0.5 of 1% of all permitted burn area. So in other words, if you look at this record of 240,000 different burn permits, almost all of those and almost all the acres that were burned fell within the conditions that satisfy the burn window as described by these 3 different conditions. Now, if we want to take that and we want to look forward, the question then becomes, where do you get that data? We used data from a data set called MACO, which is the multivariate adaptive constructed analogs data set. This is statistically downscaled climate change data at the resolution of 4-kilometer blocks. We had 18 different models. So what you'll see in the next few slides are an average of the output of all those. And then we used 2 different what are called representative concentration pathways. What those are is we don't really know what the atmospheric chemistry is going to be like 80 years from now. That reflects things that we just don't have a good handle on. That might be population growth, it can be new technology, which limits carbon dioxide or other emissions. So what these RCPs do is they provide us with a suite of potential changes in atmospheric carbon dioxide. Something like a really, really big change, RCP 8.5, represents an additional forcing being added to the climate system by 2100, and that's oftentimes considered to be sort of a business as usual model. A version that sort of builds in some type of curbing of carbon dioxide emissions would be something like RCP 4.5. And you can sort of see what happens in terms of the carbon dioxide output in these, and then how that translates into actual values of global mean temperature change. So the point to these is we don't know what it's going to be, and we're not saying that it's going to be one or the other. I'll try and present you with a couple of different scenarios as to how climate might change, and then what the implications are for prescribed burning given that. Okay, so here you are. So what you'll see are 3 columns. This represents, if we look at the percentage of days for 3 different seasons, basically winter, springish, and summer, the percentage of days that fall within those 3 burn window conditions during that time. And this is looking at historical data from the mid-70s up through 2005. If we project forward, so this is end of the century, this is for our less CO2 laden atmosphere, and this is for sort of the worst case scenario or the business as usual scenario. What we see is the percentage of days that would be available for burning given those current thresholds really doesn't change a whole lot during winter. And in fact, there's some parts of the Southeast where there actually are going to be more days that become available when you talk about places at higher elevations, or some of those areas that are along, say, the northern edge of our region, because basically that'll open up some opportunities in spring, since that time of year will maybe be a little bit warmer, a little bit drier. What's very different is what the implications are when it comes to spring, but especially summer growing conditions. So in summer, we go from something like this, where for most of the region, 50 to 60% of the days are available for burning. They meet those criteria. But if we go forward under the RCP 4.5 scenario, or even more so with 8.5 scenario, what you're saying is huge regions of the Southeast that over the summer might only have 2 or 3 or 5 days of burning within a typical month. That makes it hard to plan. It makes it hard to control. It makes it dangerous for a number of different reasons as far as meeting certain management goals. So what we see, just to sort of pull that up concisely, looking at future climate changes in the winter, probably not a big impact on burning availability. Changes in summer, though, you see a really, really distinct pattern of reduced options that you can implement prescribed fires in these areas. And that gets especially bad as you get, especially towards the southwest corner of the range and in areas in Florida. This is just another way of thinking about that. So what you see here is this is 1950. There are, each of these little pixels are rows. These run up to 2100. This line represents that transition from what we're calling the historic data or benchmark data to the projections as we go forward in the future. And then each column represents a month from January over to December. Colors are the same. So basically bright red would be no days available in a given month in a given year. Darkest green would be all of the days in that month would meet the burn window thresholds or criteria. So what you see as you go through this is, relatively stable patterns through the historic data. But once we get to about mid-century, what we start to see is increasing amounts of red. And again, those are the days where we have fewer and fewer and fewer days that are going to be available to conduct prescribed fires. Okay, that's if we summarize all of those 4-kilometer pixels for the entire Southeast. Now, that's not reasonable in terms of folks managing specific areas. So we can pull out and we can look at individual burn units or individual management areas. These are 2 that we looked at, but we have others as well. So this is looking at Big Cypress National Preserve in Florida, and then Chattahoochee National Forest, which a number of you guys I'm sure are familiar with. Same thing, months across these columns, and then individual years starting from 1950, running up through 2100. The other thing we did here is we pulled out which specific variables were becoming more constraining through time. And what we saw is that, and it makes it appear that it's 100%, but there is some limitation due to relative humidity as well. But the thing that really changes the most and really constrains future burn windows is increasing temperatures. Okay, so we see this especially in the summer. It limits summer burning. It becomes less of an issue as we go into fall, winter, and then spring. And then these transitional series or these transitional months, that's something I'm going to come back to a little bit. All right, here's another way of looking at it. And this is just for summer. What you see are 6 different management units. So we've got Kisatchie National Forest in Louisiana, Ouachita National Forest between the lakes, Uwharrie, not too far from where I am, just over into North Carolina, Chattahoochee National Forest, and then again, Big Cypress down here. And what you see for every one of these is a timeline starting from the historic baselines in the 50s up through 2005, and then projecting climate conditions forward into the future. And then the dark line represents sort of observed burn window probabilities, maybe 80 to 70% here in the case of Ouachita. But the dashed line represents what happens as we go forward in time. So what we're saying is this huge constraining ability of people to conduct prescribed burns within existing thresholds For all of these different places we look at. Chattahoochee, not as much of a problem, but we see it really distinctly in places like Big Cypress or Kisatchie, what those types of impacts are going to be. All right, now some of you guys may be pulling out your hair or other things saying, but it isn't just, it isn't just temperature, it isn't just relative humidity. We know that. So I have the slide here, which is to sort of emphasize what we're saying and what we're not. Okay, it's 3 variables, and we get that. We know tactical decisions involve a lot of other things, whether that's atmospheric instability or wind direction and not just speed, days since last rainfall, smoke management, and all of those kind of things. We understand that. We also know that if you try and take the global climate data and you look 80 years down the road, we don't have the ability to predict those types of things. What we do know is that these 3 basic parameters, just as a first cut through, provide a lot of concurrence with existing burn windows and permitting in the 2 states that we looked at. So in a way, we like to think about these almost as this is sort of the best case. If the only 3 things limiting whether you burn are wind, humidity, and temperature, you're already seeing areas where it's going to be really, really problematic. Those are oftentimes tied in with atmospheric stability and smoke dispersal issues. So when you think about individual prescribed fires, that's true. What we're sort of positing or what we're contending is that these projections really shouldn't be used as individual event management schemes, but rather these should be used by managers and decision makers to inform adaptation strategies that are developed in response to, and even better, in anticipation of changing wild and fire regimes as we move forward. So in other words, don't think of this as being guidance for individual fires. This is how do you start planning and how do you start accommodating these types of changes 10 or 30 or 50 years down the road? What are some things to consider?
John, 2 minutes.
Okay. So what I'll say is when we think about this, you guys are actually thinking about these things. We did a survey recently that I can talk to some of you guys offline about if you want. We surveyed and got responses from about 300 longleaf pine managers, and almost half of them are expecting burn opportunities to be somewhat or greatly reduced within the next 30 years due to changing climates and other types of factors. So it's already on people's minds that they're thinking about this. We also asked those folks, if you look at 3 different time horizons, we said, to what extent do you think future climate change will affect your prescribed burning decisions? And what we see is those who said not at all, going from, or a great deal, excuse me, going from very few all the way up to more than 40 or 50% as we look 30 to 50 years out. But we also see a lot more uncertainty. So people are thinking about it, but what they're looking for is guidance as to what's going to happen. By the way, we also asked about urbanization and land use, and it was even more telling. And we bring this up just because one of the constraints that was regularly cited in our surveys was the issue of urban development and wild and urban interface. So we're talking about climate change here, but we have a companion piece to most of the things that I'm talking about that also focus on its interactions with land use change. All right, so to wrap it up, here's the idea. So if we try and connect the dots on this, opportunities for prescribed burning, which we know is the best management tool for limiting wildfires. Not the only one, but the best one. And that's going to become more and more difficult and less predictable in summer and spring, at least for longleaf, because that's what we focused on in our survey. Fire managers believe that urban growth and climate change are going to increasingly constrain what they do by altering fire weather and by putting more and more people in those areas that they might want to burn in. At the same time, prescribed burning is going to become more challenging. We've got wildfire probability also increasing. That's the sort of stuff that we did in that first paper that I alluded to. So the question is, how do managers adjust their activities to meet that challenge by urban growth and by changing fire weather? What that might mean is exploring different approaches. Do you burn earlier in the day? Can you shift seasonally? Can you broaden your burn windows? If you do any of those things, how does that change maybe what your management goals are? What are other complicating factors with doing that? Just doing that runs into maybe other constraints. So that might be people, it could be resources or equipment, it could be money. It can be greater year-to-year variability. It could even be something like COVID, which, as we talked about earlier, made, at least in some areas, it difficult to burn over the course of the last year. If we broaden the temperature threshold in summer, what are the implications for the health risks for people who are conducting the burns? So where this sort of gets us to is this idea of developing an early warning system to identify changing prescribed burn opportunities and risks. That's a grant that's been funded. Again, it's something that Kevin and I and Adam Tarando and other colleagues are working on. So that's something that we just started and something that will then be evolving over the course of the next couple of years. And I figured by this time of the day, Kevin was probably getting tired, so I would do my own transition on his behalf, maybe building up a little bit, I guess, about what the implications of that are. If you all are interested in this kind of stuff, you can leave this up or just in the Q&A, ask for more about this. The things I've talked about come from 3 different papers that we published or are about to have out. And then all the data that I've talked about, these are all available through USGS downloads. So if you're interested in that, I can point you towards their data portal. And thank you all.
Thank you so much, John. We appreciate you guys doing this kind of research. And thanks to Southern Fire Exchange for linking managers and practitioners and getting that information out, because we really do read these studies and take the stuff into consideration when we're bringing crews on or just planning for the future. Need money, need more money.
They were
stuff
great,
like that.
as was Longleaf Alliance, and even Jen
Absolutely.
at Surpass as well.
Absolutely.
We're great with all this.
We do have one question.